All right, so we left off at presentation 10, slide 12, and we were looking at variables. And one of the main things, is like how do we declare a variable and assign it, and basically initialize variables. And so one of the things it brings up is lexical elements. And so that colon equals right there is a lexical element. And I put a little link there to lexical elements. And this is the language specification for Golang. Sometimes I find the language specification is more explains things in a way that is better than like the effective Go document. Sometimes I find that effective Go explains things better than the language specification. But those are both places I'll look. I'll just do Golang spec, and check out how does Golang spec talk about this subject. And I'll also do Golang effective Go, and I'll look at see how effective Go talks about this subject. And lexical elements, comments, tokens, right? Semicolons, identifiers, like what an identifier is. Identifiers name program entities such as variables and types. Okay, so it's just basically variable names. An identifier is a sequence of one or more letters and digits. Okay, letters and digits. The first character in an identifier must be a letter. Cool, right? And then everything after that is optional. So I could have a variable that's just named letter A. And this is like pretty much the example we saw when we were talking about B and F. Or I could take A and I combine it with either another letter or Unicode digit, which would be maybe a number. And if I click on letter, does that take me anywhere? Letter. So here's a letter. It's a Unicode letter, or it's an underscore, right? Because we could do underscore, we'll see, for variables which aren't used. And so they say that has to be an identifier. Right? And so, we learned kind of what an identifier is. We learned, that's where they actually specified in the language specification how variables are named. And so here are keywords, and then here are operators and delimiters. And so here's that colon equals operator. Sorry, I almost said delimiter. And that's a lexical element. And so I was kind of curious, well, lexical, that's somewhat of a new word for me. So I just Googled it. And of or relating to the words or vocabulary of a language, relating to or of the nature of a lexicon or dictionary. Pretty cool. So again, just trying to understand, the language programmers use when they're talking about things and making so it's not foreign to us when we're like lexical. Heard of Lexus? Not lexical. And so just a little reminder that when we talk about variables, there's 3 words, and sometimes there's confusion about those words: declare, assign, initialize. And I've done some reading about this, and all the different places I've read about declare, assign, initialize, and what their differences are, is led me to this: that basically, when you could declare a variable, right? So here I'm declaring the message string, the variable message, and it's of type string. I'm just declaring the variable. Nothing's assigned to it, right? And then on the next line, I assign the string hello world to the variable. So this is declare, var message string is declare, and message hello world is assigned. When I do declare and assign all at the same time, like there, var message string equals hello world, that's initialization. and you'll hear those phrases talked about interchangeably, but that's, and you'll also begin to notice that the official documentation is very precise and specific. Like sometimes they'll say declare, sometimes they'll say initialize. Right, and so I haven't really seen assign in it. So initialize just means a value was assigned, and declare means I declared it, but nothing was assigned. So if you declare and assign, that's initialize. Here's a little exercise for you, which you will do, as homework. And then the other thing that's important to know about is this concept of 0 values. So when we just declared that one string, right here, declare var message string. Right? What happened actually was it gave it a 0 value. And so let's just see that in action. And I'm going to go into, close this one, and variables. Declare variable. And so here, so if I declare this as an int, and then comment out that line and print it, so change directories into 03, 01, and then go run var. And let me print line. There we go. And so that's a cool thing to notice too. Print will print it, but it didn't give me a new line at the end of my stuff. So it printed it, and then it just wrote 01 again, right? Like there's no new line. So I added ln there for a new line. And so now when I run it, right, it gave me 0. And so even though all I've done is declare the variable, it's been given a 0 value. So Go by default will give, different types, different values. And the value for int, the zeroed value, is 0. Right? The value for string, if I left this as a string, is just an empty string, which shows up as nothing. It's not like they say, here's 2 quotes with nothing between them, because those quotes don't print. So that's zero. That's the concept of zeroed value. Zero values. Let me take that out. And so for booleans, it's false. For integers, it's 0. For floats, it's 0.0, and it's empty string for strings. And for everything else, it's nil. For pointers, functions, interfaces, slice, channels, and maps. We're going to learn about those types. So maybe when we were seeing that one thing where we did the new MD5, whatever it was, hash, and we got H, and we kind of tried to print that out and gave us the in-memory address, and then a bunch of zeros. That looked kind of like a slice that had just been, initialized with a bunch of zeros, right? So been given 0 values. So let's talk about scope. The scope of a program in Go, and there's a nice image here on Caleb's book. Sorry, that takes me to language spec. Let me go to Caleb's book. So here are the different areas of scope. And inside that, you even have curly braces inside a function. So you could have a function, and then you could create scope within the function that's just inside curly braces, and that's it. And Caleb took all this information here. Go's lexically scoped using blocks, and he took all of this information, and he basically said, here's what the language spec says, and let's go through and look at each of those things and what that means. And so I kind of went through all that and translated this into a bunch of examples to show us, And so here's package level scope. And so I'm in package main, and I declare varx int at the top level, at the top of my package. It's not inside a function. And so that's accessible anywhere inside the function, or anywhere inside the program. I'm sorry, anywhere inside the package. Thank you. Finally, I got it. That's package level scope. And so here's an example illustrating package level scope. We have 3 files. Main.go is on the bottom. And then we have model and controller up above it. And I call it a model and controller because sometimes with web programming, you'll hear about the model view controller architecture or whatever, MVC architecture. And model is where you store your data. So it's basically, hey, all the stuff dealing with data is going to go into the model area. And that could just be files or folders called model. And view is how you display everything. And so anything that ends up producing a view for the user, you put it into the view folder. And controller is kind of taking the data from model and then doing whatever it needs to do to give it to the view, get it ready for the view and give it to the view. And so controller would be like another folder. And so, people talk about the controller being the glue between the model and the view. So that's like just a really MVC, quickie definition. And so I said model up at the top there, and I put some data. I have a variable sheriff, and it's of type string, and set it equal to boss hog. I was thinking about Dukes of Hazzard. And then I went to the controller, and well, the controller is going to get the data from the model, and it's going to provide it to the view, which is main in this instance. And so sheriff is a uppercase is a function that returns the lowercase sheriff. So it's kind of like a getter. And then in main, when I call sheriff, the function uppercase, it's case sensitive, then it will produce, you can see down here in the terminal, boss hog. right? So it prints that out. So a couple of interesting things are happening here. One, the scope of sheriff on line 3 at the top in model, lowercase sheriff, that's limited to the package characters. And even though I've declared that on one page model Go, that's accessible on another file, controller Go, right? Because those files are in the same package. And so this is package level scope on line 3 up there in model var sheriff string. But because it's lowercase, I can't access that outside the package. So we've already talked about this a little bit, that uppercase means it's public, lowercase means it's private. And so the scope on that is package and it's private to the package. The next one, in this next file, controller.go, I've made the function uppercase. And this is the way the Go documentation recommends that you do a getter. They kind of, you don't say get sheriff, right? You just say, hey, it's sheriff uppercase. The lowercase was the private variable, and sheriff uppercase will go get it. And we know that that's the getter and that it's public because it's the uppercase. What's it get? It gets sheriff. And so there it's getting the value of the lowercase sheriff and returning that. And so when this is callable outside the package, that function, because it's uppercase. And so you can see that happening on line 9, right? Cool. So this would be invalid. Right down here, I'm trying to just call from the characters package the lowercase sheriff, and I can't access that because it's lowercase. So the scope of it is limited to the package. It's private. I did? Yes. How do you spell it?
1 R, 2 Fs.
1 R, 2 Fs. Did you have to look that up to verify that? Yeah. So here I capitalized the variable name, and then that works, right? My sheriff name, I now made it capitalized, so that's now public outside the package. And so here's another example of package level scope, right? X is just declared at the top level of a package, and it's accessible by different functions within that package. And this might not be something that would be desirable, in terms of limiting variable scope. And so when we get to functions, we're going to look at how we could use closure, basically enclose around something, right, to limit variable scope. So we'll see that coming up. And here, this obviously doesn't work because on line 6, that's where X is initialized. And the scope of that is, on line 6, is function scope. So we can't call it on line 11 because that's a different function. It's outside X's scope, outside the scope of X. And imports have file scope. So if I import something in a package, right, I can't use that in another file within the package.
Say that again?
Yeah.
So these are both package main. They're two different files. One is called one.go, and the other one's called another.go. Two files within the package. You can see that right here in the folder. Right, we got these two files right there. And in one file, I'm importing format, and in another file, I'm trying to use it. And even though they're in the same package, the scope of an import is file. All right, so you basically have to, on each file, you got to have your imports that are used on that file at the top of the file. It makes sense. Otherwise, you're like, did I import this? Where did I import it? And just take a moment to sort of like pat yourself on the back or appreciate what you've learned so far in just 2 weeks and 45 minutes, right? Because you're like, oh yeah, packages can have multiple files, and this is not the main package, or this is the main package, so it doesn't have to have the same. The folder doesn't have to be the name of the package, right? If this wasn't package main, we would have to have the folder be, well, we'd have to have the package be 07_invalid-scope, which wouldn't work because it's not starting with a letter, right? Because it would have to be, the package have to be the same as the file, the folder name. So here's function level scope. Again, And this is not valid, so there's no variable hoisting or anything like that, like in JavaScript. So you can't use something before you declared it, assigned it, initialized it.
So if you flipped it, then it would work?
Yeah, that does work. That does not. I mean, this is stuff that you'll learn as you code, experiment with. And so this is also not valid. So, that X has got function scope there. And curly braces can also provide scope, so we could do that. And then this would not work, even though we're in the same function. It's kind of interesting. So you could look at Caleb's book there with that link to learn a little bit more about scope if you want to read through everything. And an important takeaway is this entire idea of capitalization, public, uppercase, private, lowercase. And we already saw this. It's that sheriff example. So let's just illustrate that. So here's another example of like, hey, here I actually called a variable uppercase, and you can see I'm getting a little bit of an error, obviously. And so WebStorm saying, you can't do that. And I thought, oh, well, great, it's uppercase. It's inside, our package. Can I now use it down here? And when I call that package, no, you can't, because the scope of that is just that function. I need this to be up here at the top level for that to work. And then I couldn't use the colon equal lexical element, the colon equal way of writing code, idiom. I'd have to do var outside of a function. So there's so that's basically another way I could do it, but pretty similar to what we've seen before. I'll just let you process that for a second.
Now, is it private if you do just the first letter lowercase, and then you can have another capital? Is it still private?
It's still private.
So what
first letter.
Thing that makes it public or private is the
first letter. And then you should use camel case after that for multiple words, but you should try to stick with single words that are short, evocative, concise, err on the side of brevity.
What's the point of using a one-letter variable? Like variable X, why would you do that? It seems like it'd be
There's just a tradition. Yeah, it is confusing, and you should name your variables to provide clarity and to be self-documenting as much as possible. And like there's certain traditions in programming, like when you do a loop, your iterator variable is usually your I, and people just know that's the iterator, right? So there's this tug and pull between keeping your code brief, so it's readable, but then also having it be self-explanatory. So that's not a good practice to name things X, Y, Z, because then you're like, I don't know what all this does, but it's much better to be like grade, average, or AVG.
So does the making it a public variable, does that widen the scope of it to the whole package, or what?
So the scope of Sidekick is
File, right?
the scope of Sidekick is the whole package because it's at the top level of package. So any files within package could access Sidekick. So we have two different files accessing Sidekick.
But only inside this file, model.go, right? I mean, if you go to another go with the same package.
No, Sidekick's accessible right there too, and this is a different file in the same package.
Okay, so it's throughout the package.
Yeah, throughout the package. So
What was it we just saw earlier? Where
it's pretty much the same thing. The sheriff one?
yeah, I thought
Yeah, it's pretty much the exact same thing.
it didn't go to the next file because even though they had the same package name.
So here the variable does go because it's uppercase. So it goes to a different file in a different package. We could call it. But here it will not go because it's lowercase. Though I can still access it from different files in the same package. So two files, same package, sheriff can be used.
Can be used.
Yeah,
Okay,
lowercase.
I got the,
That lowercase sheriff in another package? No.
got it, okay. I had the
And
wrong.
that's pretty much this here too. Sidekick. Lowercase function, I can't, import that package and use that function. So here we got lowercase function side k, and that won't work down here.
Because we didn't import that package.
No, we imported the package characters right there. So characters, and that's this package. And so it now has this other package can now access anything in characters which has been made public, which means uppercase. Good questions, Bob. Just take some time.
Yeah.
I mean, lucky for me, I get to sit here and prep this stuff all the time, right? And then it's like I become more familiar with it. And it's like, I think I've shared this with you. The more you want something, it's like what I learned from my dogs, right? I shared that with you? The more you want something to stick, the more you got to roll around in it. Everything you need to know about learning, you can learn from your dog, watching your dogs. So there's an exercise to help reinforce these concepts. And then the next concept, which is good to know about, is a blank identifier. And it's for a variable you don't want to use. And so sometimes Go will not allow you to declare a variable and then, declare it and then not use it. And that's an error because it's like, well, why is it here if you aren't going to use it? Which makes sense. But if there's sometimes functions that will return multiple things, and I don't need all of them, so you just put an underscore, a blank identifier, and the underscore. Maybe I should add the underscore in right there, just so people can see what a blank identifier is. Because blank identifier, maybe it doesn't make sense. That's a blank identifier. So let's look at that. So here's a contrived example, right? So this is invalid code because C is not being used, even though it's been initialized. But if I was to do this, just put that blank identifier, the underscore character, that's fine. Because now I've told Go, look, I know I'm initializing something, and I know I'm not using it. I know what's up. And Go's like, okay, you know what's up. Because I might want to come back and use that later or something. So, whatever is stored is thrown away for that variable. And so you'll sometimes use a blank identifier with this idiom right here. For key value is, I'm not sure if I'm using that word idiom right. I got to look that up. Sounds good. For key value range, and this is like the syntax for looping over a collection of data. And so you want to commit this to memory. This is like a really important little chunk of code. For key value is equal to range, and then some iteratable object like a map or a slice or array or something like that. And so here I'm throwing away, in the example down below, I'm throwing away the key. I don't need the key, just give me the value. Right? But when you range over something, it will return key and value. So just a little bit of review. Can occur anywhere in your code as the var a string, or var d string, or multiple assignment var bc string. Right? You can put that anywhere in your code, or constant p string, or constant q, and let them figure it out, equals 42. You can put that anywhere in your code. You can only do the colon equals lexical element inside what? Inside functions. All right. You can do multiple assignments. It'll figure out the types. You can mix the types in a multiple assignment. The double quotes and the backticks are for strings. We'll see a little bit more about what single quotes does. And we learned about capitalization, public-private. We learned about the blank identifier, and we learned about declare, assign equals initialize. Did you realize there's going to be this much programming? There's some exercises there for you to do to reinforce everything. Oh.